Okay, so I've done similar problems before, but this time we're just going to do it all in terms of function notation. So let's have a look at the key parts of this question. So a householder has 6 laying hens, could be interesting. A rectangular enclosure to provide a maximum area for the hens. So we need a maximum area, and we've got 12-metre length of fencing wire. So I need to construct a function that will give the area of the enclosure A in terms of L. Okay, so what that means straight away is that I need some function called A of L equal to the area. Okay, so what do we do? What do we know? Well, I've got a rectangular function, so I've got a rectangular function, and the perimeter, I've got a length and a width, and I do know that the perimeter is 2L plus 2W, and that is equal to 12 meters. So I've got 2L plus 2W is equal to 12. Divide everything by 2. So I've got that. All right. I've also got the area of a rectangle is length times width. Now straight away I should be able to see here that I've got two different variables in here, length and width. I want a function, all right, that's just in terms of L. So how could I find some sort of relationship for W? That comes back over here. I know that W is equal to 6 minus L. So if I substitute that in for width, I can say that the area L is equal to length times 6 minus W. So if you like, A of L is equal to 6L minus L squared. So if I sketch this graph, now I'm only worrying about the positive quantities because that's what it is. I know it's a negative parabola, and from here I know that the intercepts are going to be at, well, actually let's undo that. The intercepts are going to be at 0 and 6, and I'm going to put them as hollow dots because I can't have a length of 0 meters or a width of 0 meters, or a length of 6 meters I should say, because that would make my graph, the shape, sorry, not a rectangle. So it's a negative parabola. So it's not the best parabola. And I'm only going to draw it over that section there. So given we've been talking about things like domain and range, we can see straight away the domain of this graph is equal to 0 to 6, not inclusive. And the range, well, how do I find this maximum? Hopefully from our parabola knowledge, we know that the vertex is going to be in the middle of my intercept. So that's at L equal to 3. Should label my axes. There's L, there's A of L. So what happens if L is equal to 3? At L equal to 3, A of 3 is equal to 6 times 3 minus 3 squared, which is equal to 18 minus 9, which is equal to 9 meters squared. So that's the 0.39. So let's read. I've got the enclosure A in terms of L. I've sketched the graph, find the maximum area. So therefore, maximum area is equal to 9 meters squared. So we've done similar problems. The only difference is going to be we're going to use our function notation here instead of our y equals or a equals.